So far as we've examined quadratic functions, we've seen the equations expressed in two ways. In standard form, f of x equals ax squared plus bx plus c, and in vertex form, f of x equals a times x minus h quantity squared plus k. There are other ways that the quadratic function could be written, but these are the two most common, and they each have some similarities and differences. First off, notice that they have some of the constants that are the same and some that aren't. In standard form, you have constants a, b, and c. In vertex form, you have constants a, h, and k. When we use constants in mathematics, when we are representing the same number, we'll use the same constant. When we're representing different numbers, we're going to represent them with different constants. So notice what's the same here, the a value. The a is the leading coefficient of the x squared term. And remember what a will do. A is the same in both. A is going to tell you whether the parabola opens down or it opens up based on the sign. Remember, if a is negative, it opens down. If a is positive, it opens up. The other thing a can tell you is how wide or skinny the parabola is, because the value of a is going to influence that. What's different, though, about these two is the BC and the HK. These represent different things in the forms. In vertex form, the HK is representing the vertex, which is really valuable, especially if you're graphing, as we'll see later. In standard form, the B and the C are really just expanded versions of what's going on, but the C in this situation does have a value in terms of our graph. And let's examine that a little bit. Remember, x and y intercepts are going to be found by setting one or the other variable equal to 0. What I want to do is investigate the y-intercept. Remember, y-intercepts occur when x is 0. So let's plug 0 into this function. F of 0 equals a times 0 squared plus b times 0 plus c. 0 squared plus a is going to make this term go to 0 and therefore go away. 0 times b is going to make that go away. So when I plug 0 into any quadratic function in standard form, I'm going to be left with c, the constant term. That means that c is the y-intercept value. So we always are going to have a y-intercept at 0c. So the y-intercept in standard form is clearly shown right away. And that can be useful in many applications when you need to know where you're starting the process. The y-intercept is often called the starting value. So if you're in standard form, you're automatically given the y-intercept right away. When you're in vertex form, you're given the vertex right away. Both have value, and it really depends on what you're doing, whether you would prefer to have one or the other. The A, though, is the same in both.